All right, one of the things that we talked about in that subcategory was rational numbers. And there were two types of rational numbers that we discussed other than those that looked or were written as fractions. We discussed terminating decimals. And we discussed non-terminating repeating decimals. Okay, both of these types of numbers fall into the category of rational numbers. Now, because of this, what I want to do is make sure that you guys can take numbers that are in these two forms and rewrite them in their rational form, rewrite them as a fraction. Okay, so if we took something like this, the terminating decimals, you may have done something like this before. But if I want you to write 5.13, not in decimal form, but as a fraction, the way that you would do that is what? Anybody have any ideas? How could you express this as a fraction? Jacob?
513
Good. You just take all your digits with no decimals in it, so just the 5, the 1, and the 3, and then you divide by whatever the place value is for your last digit. So this 3, our last digit here, is in the what place value? Hundredths. So we're going to divide by 100, and that is your rational form. And now, you may want to enter it in your calculators to make sure it's simplified completely. So 513 divided by 100. Are there any common factors that simplify this? No, it's left as 513 over 100. Questions about that? That one's pretty straightforward. And whether you guys have actually worked at this in a class, you've probably done this before. The non-terminating repeating decimals are another case. Okay, let's take an example of one that you guys should all know the rational form of. Okay, what is the rational form of 0.333 continuing? 1/3, right? So let's go through and see how can we convert this repeating decimal into a fraction form. Okay, and here are the steps, and these are the steps that are going to work for every type of repeating decimal. Step 1, you're going to set your original value equal to x. Okay, so you're just going to create an equation from it. X equals 0.333 continuing. Next, what you're going to do is you're going to identify the number of repeating digits. Okay, how many digits repeat in this decimal? Just one, right? Just the digit 3. So what you're going to do is you're going to take that number and you're going to put that as a power to 10. So 10 to that power gives you a value of 10. You're then going to multiply both sides of this equation by whatever 10 to the power of whatever number of repeating digits you have. And so this is identify, ID. Identify the number of repeating digits, take that as your power of 10, and multiply that by both sides of your equation. So 10 times x is 10x. 10 times 3.3 continuing is, we just move the decimal one place over. This is why we're choosing 10 to the power, because 10 to the first, we move the decimal one place. 10 to the second, we move it 2. 10 to the third, we move it 3. So it makes it really easy to multiply those out. So 10 to the first, we're going to multiply, and we get 3.333 continuing. Okay, the whole reason we choose to do it this way is now when we subtract both sides, we get 10x minus x, which is 9x. The repeating values should always line up above each other. So when you subtract 0.333 from 3.333, the repeating parts cancel. We're left with 3 minus 0, which is 3. And then we can just simplify or solve for our x by dividing both sides by 9 in this case, simplify our fraction, and we confirm the rational form of that repeating decimal. Okay. All right, let's take 0.99 repeating. Okay, remember, there's two ways to express the repetition of digits. Either the dot, 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 the pattern will continue. or just a bar over the top. So this means 0.9, those 9s will continue. Okay, see if you can follow this same set of steps and demonstrate the rational form of 0.999 continuing. Step 1, set it equal to x. Step 2, figure out how many digits repeat. Again, just 1. You're going to take 10 to that power and multiply both sides of your equation by that. So 10 times x is 10x. 10 times 0.9 is 9.9 repeating. Again, we're just moving the decimal one place to the right. We can then subtract both sides. We get 9x is equal to, here the repeating digits cancel, leaving 9 minus 0, which is 9. And so what is the rational form of 0.99 repeating? 9/9, which reduces to 1. So this is the proof. Have you guys ever proven 0.9 repeating is equal to 1 in any of your math classes? And often that happens at the 7th, 8th grade level. Okay. But this demonstrates that 0.999 is equivalent to 1, which is a true statement. Okay, let me take this next example. I want you just to take a moment or two, see if you can find the rational form of 3.151515, again repeating. Okay, so here are your steps. Set x equal to your given number. Figure out how many digits repeat. In this case, there are 2, the 1, 5, right? So we're going to take 10 to the second. We're multiplying both sides of the equation by 10. 10 squared is what value? 100. So we get 100x on the left. Move the decimal 2 places over. Again, you always just move it the number of digits that repeat. So we get 315.1515, so on. Okay. Subtract both sides. We get 100x minus 1x is 99x. Here, the repeating portions are going to cancel each other out. We have 315 minus 3 leaves 312. Divide both sides by 99. And when you do that, you can double check it and see, does this fraction simplify at all? So if we took 312 divided by 99, enter, we get 104 over 33. So there is our rational form. Anytime you're writing your rational form, make sure you write it in the simplest form possible. And you can confirm this. Again, this is one of the nice things about these types of problems is if you just hit the green diamond button and enter, it should confirm 3.15 continuing. You have the correct form for that repeating decimal. Okay. Questions on any of that process? Okay, I want you to try one last example. Okay, see if you can find the rational form of 15.321 repeating. All right, the process. Again, set it equal to x. Figure out how many digits repeat. This time there are 3. So we take 10 to the third, multiply both sides by that value. 10 cubed is 1000x. 1000 times this. Again, we move our decimal 3 places. So we have 15,321.321 repeating. What we can now do is subtract each side. We get 999x is equal to 15,306. Again, the repeating parts cancel. 15,321 minus 15 gives us 15,306. Divide by 999. That isolates your x. So if we take 15,306 and we divide by 999, hit enter, we have 5102 over 333, and that is the simplified rational form of that repeating decimal. Now, if I want to verify it, I simply take this, hit the green diamond button, enter, and it shows 15, 321, 321, 321. It shows that that is the correct form of that repeating decimal.